Okay, so let's explain what was going on in the last unit. We had a linear system that could be represented as ax equals b. We had a solution to that system. We're going to call it a specific solution. Sometimes it's called a particular solution. So we know an x sub s, the s is for specific, such that a times xs is equal to b. We also had a vector that mapped to 0. Axn is equal to 0. The n comes from something called the null space. It turns out to be a vector in the null space. We'll discuss that later. Then, let's see what happens if you do a times x plus xn. Well, we know we can distribute that. Why? Because a times x is a linear transformation. And then we know that a times xs is b. That came from this right here. And we know that a times xn is 0. That came from this right here. What you get then is b. So what does that mean? It means that this new vector right here is also a solution to ax equals b. Now, what if we have some arbitrary multiple of that vector that maps to 0? Well, we can distribute. We know we can bring the beta out because a times x is a linear transformation. We then know that this is equal to b, and we know that this is 0, and therefore we know that beta times 0 is the 0 vector. And therefore we get b. So we know that any vector of this form is also equal to b. And that explains why there were an infinite number of solutions. As long as you have one non-zero vector that maps to 0, you can always add a multiple of that vector to a solution and generate another solution. There are an infinite number of them. So in summary, the way to find all solutions to ax equals b is to find a specific solution. If it's a unique solution, then you're done. Otherwise, you start finding vectors xn such that a times xn is equal to 0. And with that, you can then generate an infinite number of solutions. The key now is how to find just enough vectors that map to 0 such that you can generate all possible solutions. In order to understand that indeed we have enough, you're going to have to understand something about spaces, subspaces, null spaces, and column spaces.